Right now, on the surface of Mars, the air is so thin that a body stepping out into it without a suit would not suffocate first. The water in that body would begin to boil at normal temperature, while the person was still alive to feel it. The pressure on Mars is less than 1% of the pressure around you right now. The air is almost entirely carbon dioxide. The average temperature is around 60 degrees below zero, and the ground is laced with a salt that poisons the body that eats or breathes it. This is the world we have decided to call our second home, the backup planet, the place humanity goes if Earth fails us, or if we fail Earth. We talk about Mars as an insurance policy, a fresh start, a frontier waiting for its first city. But Mars is not waiting for us. Mars already died 4 billion years ago, and everything it is now is arranged to kill the kind of life we would bring. So the real question is not when we move there, it is what happens to the ones who try. Tonight, we are going to walk out onto the surface of Mars and look honestly at what is actually there and at what it would do to us. By the end of this, you will understand how Mars died, why nearly everything about it now is lethal to human life in ways no dome quietly fixes, and why the dream of turning it into a second Earth runs into a wall the planet itself builds. I am not going to sell you the frontier. The truth about Mars is harder than the frontier and more useful, and it is this: Mars is not the place that saves us, it is the place that shows us how a world dies and why we cannot afford to lose the one we have. If you like standing in the hard, honest places out here with me, a quick like or subscribe helps these videos find the other people who would too. Now, let us begin. Mars is not a new world. It is an old one, and it is already dead. 4 billion years ago, it was not the frozen desert we see now. There was liquid water on its surface, standing in lakes and running in rivers, under an atmosphere thick enough and warm enough to let that water last. We are not guessing at this. The shape of that water is still cut into the ground, dry now for longer than there has been complex life on Earth, but unmistakable. Mars had a warm, wet age. Then it ended. The planet we are being told to think of as our future is a planet that already had its chance at being alive and lost it. You can read the loss in the surface itself. There are branching valley networks that look exactly like the system's water curves on Earth, cut by something that flowed downhill for a long time. There is a crater named Gale, where a rover has spent years climbing through stacked layers of sediment that were laid down at the bottom of an ancient lake. There is another crater named Jezero, where a river once spilled in and dropped its load of mud and sand into the fan shape of a delta, the same form a river builds where it meets a lake on Earth. Deltas and lake beds and river valleys do not form in a dry, near airless world. They form where liquid water stands and moves and stays. Every one of them is a fossil of a Mars that could hold water on its surface, which means a Mars with a thicker atmosphere and a warmer climate than anything it has now. So what changed? The short answer is that Mars lost its shield. Early in its history, the planet had a global magnetic field, generated deep inside it, wrapped around the whole world the way Earth's field is wrapped around us. That field is not decoration. It is what holds an atmosphere in place against the sun. The sun does not only send light, it sends the solar wind, a steady stream of charged particles blowing outward in every direction. And when that stream hits an unprotected atmosphere, it strips it, particle by particle, and carries it off into space. Earth keeps its air because Earth's magnetic field deflects that stream around us. Mars lost its field, and once the field was gone, there was nothing between the Martian air and the solar wind. The stripping began and it never stopped. As the air thinned, the planet could no longer hold its water. Liquid water needs enough pressure overhead to keep from boiling away, and enough warmth to keep from freezing solid, and as the atmosphere bled into space, Mars lost both. The The water on the surface froze into the ground or rose into the thinning air and was lost with the rest. The rivers stopped, the lakes dried or froze. The warm, wet world cooled and dried and went still, and it has been still for billions of years. This was not a sudden death. It was a slow suffocation, an atmosphere leaking away over a span of time so long that the draining itself would have been invisible to anything watching. But the direction never reversed. Mars only ever got thinner, colder, and deader. And it is still happening. A spacecraft named MAVEN was sent to Mars specifically to measure this, to catch the planet in the act of losing its air, and it did. Even now, with most of the atmosphere already gone, the solar wind is still stripping something like 100 grams of it away every second, and in the young, fierce days of the early sun, the loss was far greater. Most of the air Mars was born with is simply gone, scattered into space, and it is not coming back. What remains is a thin skin of mostly carbon dioxide, pressed down to less than 1% of the weight of air you are sitting under right now. That is the leftover. That is what 4 billion years of leaking produces. A near vacuum with a memory of a thicker sky. This is the thing I want to fix in place before we go any further, because the whole video rests on it. Mars is not a blank slate waiting for life to arrive. It is the site of an ending. It is a world that had the things a living planet needs: an atmosphere, liquid water, a shield against its star, and lost all of them in order until nothing was left but cold rock and thin poison air. When you look at Mars, you are not looking at a frontier that has been waiting patiently for us to show up. You are looking at what is left when a planet's ability to support life dies. We did not arrive early, before the story started. We arrived long after it ended, and we are standing in the ruins, calling them a beginning. I have to be honest about the one thing we do not know, because it matters and because it is the live edge of all of this. We do not know whether anything was ever alive on warm, wet Mars. The conditions for life may have been there, water and warmth and time, and life may have begun, or it may never have started at all. We have not found a confirmed sign of it either way. A rover is on the surface right now, collecting and sealing samples of Martian rock that might one day, if they are ever carried back to Earth, finally answer the question, and those samples have not been brought home. So hold that thought, because we will come back to it. We know for certain that Mars lost the ability to stay alive as a world. We do not yet know whether it took anything living down with it. Let me put the timescale in a form that lands, because 4 billion years is a number that slides past the mind without leaving a mark. Mars held liquid water on its surface until roughly 4 billion years ago. The Earth at that same moment was barely getting started on life of any kind, and complex life, animals, anything you could see, was still more than 3 billion years in the future. So the death of Mars is not recent history. The water stopped running on that surface before there were trilobites in Earth's oceans, before there were fish, before there was anything on land at all. When you look at those dry valleys, you are looking at a catastrophe so old that the entire visible history of life on Earth has played out since it finished. Mars has been dead as a living world for almost the whole age of the solar system. And the evidence of the wetter world is not limited to the shapes of valleys and deltas. The rovers crawling across the surface have found the chemical fingerprints of that water locked into the rocks themselves. They have found clays, the kind of minerals that form only when rock sits in contact with water for a long time. They have found salts and sulfates left behind as ancient water evaporated. They have found rounded pebbles of the sort that only tumbling in a stream bed produces. The rock itself remembers the water, in its minerals and its shapes long after the water is gone. This is not a guess or a hopeful reading. The wet past of Mars is written into the ground at the level of chemistry, and it is unambiguous. There was water here for a long time, and then there was not. What there is no clear evidence of, and this is the honest gap, is that any of that water ever came alive. Warm, wet, long-lasting water is where we think life can begin, and Mars seems to have had it, which is exactly why we keep sending machines to look. But looking is not finding. So far, nothing the rovers have examined amounts to a confirmed sign of past life. Only the conditions that might have allowed it, the samples that could finally settle the question, are sitting in sealed tubes on the Martian surface right now, waiting for a mission to carry them back to Earth that has not yet happened. Until then, the most we can honestly say is that Mars had a moment when it might have begun and then lost the world that moment depended on. Whether anything was alive to feel that loss, we do not know. There is a reason Mars died and Earth did not, and it comes down to size. Mars is a small world, about half the diameter of Earth and roughly a tenth of its mass. A small planet holds less heat in its interior and loses it faster, the way a small stone left out in the night goes cold long before a boulder does. The magnetic field that shielded Mars was generated by the churning of molten metal in its core, and that churning needs the core to stay hot and moving. On a small world, the interior cools and stiffens sooner, the churning slows and stops, and the field it was generating fades away. Mars, being small, cooled too fast, and its field died young, and once the field was gone, the rest followed. So the death of Mars was not bad luck so much as a consequence of its size, written into the planet from the day it formed. It was always going to be the world that lost its shield first. And once that one-way slide begins, nothing on the planet can reverse it. A living world like Earth has cycles that put things back. Water that evaporates and rains down again, carbon that goes into rock and comes back out of volcanoes, a whole set of loops that keep the conditions for life topping themselves up. Mars lost the engine that ran its loops. The air that left did not come back. The water that froze did not thaw. The warmth that bled away did not return. Every change went one direction, toward thinner and colder and deader, with nothing to push the other way. That is what makes it a corpse rather than a sick patient. A sick world might recover. Mars has no mechanism left to recover with. It used them up, or lost them, billions of years ago. And the loss is written across the whole face of the planet, not just in a few craters. The northern half of Mars is lower and smoother than the south, a difference in the land itself that fits with that lower ground having once held standing water. A sea spread across the northern plains while the highlands stood above it. The details of that ancient shoreline are still argued over, and I will not pretend the picture is settled, but the direction of the evidence is not in doubt. Wherever you look on Mars, you find the marks of water that is no longer there, deltas with no rivers, valleys with no streams, lake beds with no lakes, salts left where pools dried away. The planet wears the outline of a wetter self that nothing has ever washed away, because nothing has run across it in billions of years. But the deeper subject tonight is not what Mars was. It is what Mars is, and what that dead world would do to us if we went to live in it. Because the same death that emptied the air is exactly what makes the planet lethal now. The thin atmosphere, the lost shield, the frozen ground, these are not just the symptoms of an old catastrophe. They are the conditions a settler would have to survive every second forever. So let us start with the simplest and most immediate version of the question. Take a human body and set it down on the surface of Mars, unprotected, the way you stand outside on Earth without a thought. What does the dead world do to it? The first thing that kills you on Mars is not the cold, and it is not the lack of oxygen. It is the pressure, or rather the near total absence of it. The atmosphere on the Martian surface presses down with about 0.6% of the force of Earth's. That is not thin air. That is a near vacuum that happens to have a little carbon dioxide drifting through it. And a near vacuum does something to a warm, wet body that most people never think about, because nothing on the surface of Earth ever exposes us to it. There is a pressure, well known to anyone who studies high-altitude flight, below which water boils at the temperature of the human body. It is called the Armstrong limit, and on Earth it sits around 19 kilometers up, far above the height where any airliner flies, far above the height where a human can survive, even with all the oxygen in the world piped into their lungs. Above that line, the air is so thin that the water in your body no longer stays liquid at body heat. It turns to vapor. The Martian surface is not near that line. It is far past it, at a pressure many times lower still. On Mars, the whole planet sits above its own Armstrong limit. So here is what the dead world does to an unprotected body, stated plainly. The moment it is exposed, the water begins to leave it. The saliva on the tongue, the moisture on the eyes, the thin film of water lining the inside of the lungs, all of it starts to boil, not because it is hot, but because there is almost no pressure holding it in liquid form. The body swells as the water in its soft tissues turns to gas. There is at the same time essentially nothing to breathe. The air that is there is about 96% carbon dioxide, with oxygen making up a fraction of a single percent, so even a desperate breath pulls in nothing the blood can use. Consciousness goes in well under a minute. Death follows close behind, and all of this happens before the cold has even finished its work. The cold is real, and on any other world it would be the headline. The average temperature on the surface of Mars is around 60 degrees below zero on the Celsius scale, colder than the coldest natural place ever recorded on Earth. And at the poles and on winter nights it falls far below even that. But for an exposed body, the cold is almost an afterthought, because the pressure and the lack of oxygen have already done the killing long before freezing matters. That is how hostile the air is. It has three separate ways to end you: the vacuum, the suffocation, and the cold, and the slowest of the three is the one that would freeze a body solid. The fastest does its work in seconds. I want to be precise about what this means, because it is easy to think of Mars as a hard but survivable place, somewhere you could step outside in a breathing mask and tough it out, the way you might on a high mountain. That picture is wrong, and the difference is not small. On the highest mountain on Earth, the air is thin and cruel, but it is still air, still around a third of the pressure at sea level, still something a body can work against. The Martian surface offers less than 1%. There is no toughing it out. There is no holding your breath and making it to the next shelter. Without a sealed, pressurized suit, the surface of Mars kills as quickly and as certainly as the open vacuum of space, because in every way that matters to a human body, that is what it is. Now this part is survivable, and I want to be fair about that because the channel does not exist to overstate things. A pressurized suit and a sealed, pressurized habitat solve the immediate problem. People already live for months in the vacuum of low Earth orbit inside sealed metal, and the same approach works on Mars. So the air by itself is not what makes Mars impossible. It is what makes Mars unforgiving, because the solution has no margin in it at all. Every person on Mars would be alive only because a wall a few millimeters thick is holding a breathable pressure in and the near vacuum out, and that wall has to hold perfectly every second for the rest of their lives. A tear in a suit, a failed seal on an airlock, a crack in a habitat wall, a blown valve, and the dead world comes straight in, and it works in seconds. On Earth, a hole in the wall of your house is an inconvenience. On Mars, the same hole is a death sentence with a timer measured in breaths. That is the thing to carry forward from the air. It is not that Mars is a little harsher than the worst places on Earth. It is that the surface of Mars is actively, immediately lethal in a way no place on Earth is, and the only thing standing between a settler and that death is engineering that can never once fail in a way it cannot fix in seconds. The dead world is patient. It does not need to break the wall itself. It only needs the wall to break, once, anywhere, and it is always pressing on every wall, everywhere, the whole time. There is a detail in this worth slowing down on, because it shows how completely the surface refuses a human body. The pressure on Mars is so low that you could not save a person with oxygen alone. On a high mountain, the problem is that the air is thin, and bottled oxygen helps, because there is still enough pressure for your lungs to pull that oxygen into your blood. Past the Armstrong limit, oxygen does not help, because the pressure is so low that your lungs cannot drive it across into your bloodstream at all, and the water in your tissues is busy turning to vapor regardless of what you breathe. A mask is useless. Only a sealed, pressurized suit that holds a real pressure around the entire body will do, which is to say, only by carrying a piece of Earth's pressure with you, wrapped around your skin, can you exist on the surface for 1 second. There is no lighter version. It is full pressurization or death. And even inside a sealed habitat, the air is not simply solved and forgotten. The people there would be breathing in a closed volume, and every breath turns oxygen into carbon dioxide, the same carbon dioxide that makes up the deadly outside air. So a machine has to pull that carbon dioxide back out of the cabin air continuously, or it builds up and poisons them in their sleep, inside their own shelter, with the dead world never having touched them. Oxygen has to be generated continuously. Pressure has to be maintained continuously. The habitat is not a refuge from the air problem. It is a machine for solving the air problem every second that the people live inside, and if the machine stops for long enough, the inside becomes the outside. The cold deserves a moment too, because while it is not the fastest killer, it never lets up. The average temperature, around 60 below, is colder than the coldest day ever recorded in the most brutal places on Earth, and that is the average. The temperature swings hugely between day and night, because the air is too thin to hold heat, so a surface warmed a little by the weak sun loses it almost completely once the sun goes down. Every material, every seal, every joint in a settlement would be stretched and shrunk by those swings, every single day, forever, one more slow pressure, working against everything that has to hold. The cold does not need to kill you quickly. It only needs to keep working on the things that keep you alive. Think about what the suit actually has to be, because it is not clothing. It is a personal spacecraft, worn on the body, that has to hold a breathable pressure against the near vacuum, supply oxygen, scrub away exhaled carbon dioxide, hold off a cold of 60 below, and shield against at least some of the radiation, all while being flexible enough to let a person work. Every time a settler goes out, they are trusting their life to that machine, and every time they come back, they pass through an airlock, a chamber that has to cycle between the deadly outside pressure and the survivable inside, one without ever letting the two meet around them. Going outside on Mars is not stepping out the door. It is a procedure every time, with a machine between you and death at every step, and the dust fouling the seals of that machine the whole while. And the pressure never relents, which is the part that wears on everything. The inside of every habitat and every suit is held at a pressure the outside is constantly trying to equalize, which means every wall and seal and seam is under a steady outward push, every second, forever. A slow leak that on Earth would be nothing becomes, on Mars, a quiet emergency, the breathable air bleeding out into the near vacuum, the pressure dropping toward the line where the body fails. The settlers would live their whole lives inside containers that the dead world is endlessly patiently trying to empty, monitored constantly for the leak that has not happened yet, because the day it happens unnoticed is the day they die. There is a consequence of all this thinness that captures the whole problem in a single fact. Liquid water cannot exist on the surface of Mars, not in the open, not anywhere. Set down a cup of water on the Martian ground and it does not sit there. At that pressure and that cold, it boils and freezes almost at once, the water tearing itself apart into vapor and ice in the same moment, because the air is too thin to let it stay liquid, and the temperature too low to let it last if it could. The one substance every living thing we know of needs, in the one form life needs it, simply cannot persist out there. That is the dead world stated as plainly as it can be stated, not hostile to water in some figurative sense, but a place where water, the basis of life, is physically forbidden from existing on the surface as anything a body could use. So seal the body in a suit, and seal the settlement in pressurized shells, and you have answered the fastest killer. The air is handled at the cost of never being able to breathe freely on the surface of the world you travel to. But the moment you step down onto that surface in your sealed suit, you are standing on the next problem, because the ground itself, the dust under the boots, the soil a settler would have to dig and build and try to grow food in, is poisoned. The soil of Mars is poison, not poisoned in some loose dramatic sense, but in a specific, measurable, chemical one. Spread through the Martian dirt, almost everywhere we have looked, is a class of salt called perchlorate, and perchlorate is toxic to the human body. When a lander named Phoenix set down in the northern plains of Mars and scooped up the soil to test it, perchlorate made up something like 0.5% of the sample by weight. Orbiters have since shown that the chlorine these salts are built from is spread across the whole planet. This is not a local contamination at one unlucky site, it is a property of the Martian surface. 0.5% might not sound like much until you know what perchlorate does. In the human body, it interferes with the thyroid, the gland that runs your metabolism, by blocking its uptake of iodine. Chronic exposure disrupts the hormones that keep a body regulated, and the dirt on Mars is full of it. So the very first thing a settler would have to do with Martian soil, before growing a single plant in it, before using it for anything, is get the poison out, because food grown in untreated Martian dirt would carry that poison into the people who ate it. The ground that the dream pictures as farmland is, as it sits, a thyroid toxin spread across an entire planet. And it does not stay politely in the ground. The perchlorate rides on dust, and Martian dust is its own slow catastrophe. It is extraordinarily fine, far finer than sand, closer to a powder, and it carries a static charge, which means it clings to everything it touches. It works its way into the seams of a suit, into the seals of an airlock, into the joints and bearings of any machine left out in it. Every rover and lander we have ever put on Mars has been ground down in part by this dust, coating surfaces, fouling mechanisms, building up where it is not wanted. And because the dust carries the perchlorate, the same grit that jams the equipment is also the grit you must never breathe. Track it into a habitat on a suit, let it loose in the air the settlers breathe, and you are asking them to inhale a fine powder of thyroid poison. So look at the actual daily reality, not the poster version. Every time a settler comes in from the surface, the dust comes with them, on the suit, in the airlock, and it has to be controlled, scrubbed, kept out of the living space, because it is both a poison and an abrasive. Every system that touches the outside has to fight the same fine, clinging, charged powder working into it. The soil that has to feed the colony has to be cleaned of a salt before it can be trusted. None of this is dramatic in the way a vacuum breach is dramatic. It is worse in a quieter way, because it never stops and it is never finished. The dust is everywhere, the wind keeps moving it, and the planet has an unlimited supply. I will be fair about this, the way the science is fair. Perchlorate is not an unbeatable wall. It can be washed out of soil with water, or broken down chemically, and there are microbes on Earth that actually consume it, which some people hope could be used to clean Martian dirt for farming. So this is a hazard to be managed rather than a flat impossibility. But notice what that phrase, managed rather than impossible, keeps meaning on Mars. It means one more system that has to work, one more process that has to run continuously and correctly, one more way the settlement dies slowly if the management ever lapses, the soil if it poisons the crops, the dust if it gets into the lungs, the grit if it grinds the machines to a halt. Earth gives you ground you can simply stand on, and dirt you can simply plant in. Mars gives you a poison you have to fight, forever, as the price of staying. This is the dead world again, in a new form. The air is a near vacuum because the atmosphere leaked away, The ground is laced with perchlorate and buried in clinging, charged dust because there is no liquid water and no living system to weather it, scrub it and lock it away the way Earth's water and life have processed our soil for billions of years. A living planet cleans itself. Rain falls, rivers run, plants grow, things rot and recycle. Mars has none of that. The poison just sits there, dry and undisturbed, because nothing has happened on that surface for a very long time except dust settling and the wind moving it around. The toxic ground is not a separate problem from the dead world. It is what the ground of a dead world looks like. It is worth being clear about why the ground is like this, because it ties straight back to the dead world. On Earth, soil is alive. It is the product of billions of years of water and weather and living things, rock broken down and mixed with the remains of organisms, washed by rain, turned over by roots and burrowing life, its harsh chemistry buffered and recycled into something that can hold a plant. Martian dirt is none of that. It is broken rock and the chemistry that forms in a dry, irradiated, lifeless place, never washed, never recycled, never softened by anything living. The perchlorate sits in it precisely because there has been no liquid water moving through it to carry the salts away and no life to process them. The poison in the ground is another symptom of the same deadness. A living world cleans its own soil. A dead one just accumulates whatever the chemistry and the radiation make and lets it lie there. There is water on Mars, which the dream leans on heavily, but look closely at the form it takes. It is ice, locked into the ground and the poles, and in some places it is bound up chemically inside minerals, and getting usable water out of it means mining and processing on an industrial scale, in the cold, through the dust, with machines that the dust is constantly trying to grind down. The water is not a stream you dip a cup into. It is frozen into a poisoned, abrasive ground that fights every machine you send against it. Everything a settlement would need to pull from Mars, the water, the oxygen baked out of the rock, the building material, has to be wrenched out of a dead planet that gives up nothing easily and wears down the tools you use to take it. And the dust ties all of it together into a single, grinding, daily problem. The same fine powder is the thing that poisons the soil, the thing that must be kept out of the lungs, the thing that coats and abrades the machines, and the thing that, as we will see, can rise up and darken the whole sky. It is not a series of separate nuisances. It is one substance everywhere, doing harm in every direction at once, and there is no end to it because the entire surface of the planet is made of it, and the wind never stops moving it around. The colony would have to live inside a closed loop, and closed loops are fragile in a way open ones are not. On Earth, the air renews itself, water cycles through the whole planet, waste breaks down and feeds new growth, all of it run by a living world for free. A Mars settlement has to do every one of those jobs itself, with machines, in a sealed volume. The oxygen has to be made and the carbon dioxide removed. The water has to be recycled, used and cleaned and used again, with very little to top it up. Waste has to be processed. Food has to be grown in the poisoned soil made safe, or carried from Earth across that long supply window. Every one of these is a loop that has to close, and a loop that does not quite close leaks its way toward failure. The settlement is a small, sealed imitation of the living planet it left, run by machines that must not stop, standing in for a world. And the dust threatens even the breathing. It is fine enough to hang in the air and reach deep into the lungs, and it is sharp and chemically reactive in ways that ordinary household dust is not. Breathe it over time, and it is the kind of thing that scars lung tissue, the way mineral dusts have always done to people who worked in them on Earth, and it carries the perchlorate along with it. So the air inside the habitat does not only have to be made breathable in the sense of oxygen and pressure, it has to be kept clean of the very ground the settlement is built on and dug into, because that ground, made airborne, is something you cannot safely breathe. And because the surface grows nothing, the entire food supply of a settlement would hang on indoor farming that has to be built and run from scratch in sealed and pressurized growing spaces, in soil scrubbed of its poison, or in systems that use no soil at all, under lights, drawing the scarce power, fed by the recycled water, tended constantly. There is no falling back on the land if a harvest fails, because the land outside is a frozen, poisoned, near-airless waste where nothing has grown for billions of years and nothing will grow now. A blight, a system failure, a bad stretch in the growing chambers, and there is no field to walk out into, no other farm down the road, no wild plants, nothing. The food, like the air and the water and the warmth, is a closed system the settlers run themselves, and like the others it kills them quietly if it ever stops closing. So now seal the body against the vacuum, and handle the dust and the poisoned soil with enough cleaning and care, and you have answered two of the ways Mars kills. But there is a third thing, and this one does not come up from the ground or press in from the thin air around you. It comes down from the sky, constantly, day and night, and unlike the air and the dust, there is no wall thin enough to live behind that also keeps it out. To stop it, you have to stop living on the surface at all. Mars has no shield against the sky, and that turns out to be one of the hardest problems of all. Remember that the magnetic field is gone, the same loss that let the atmosphere leak away. And the atmosphere that remains is too thin to do the job our air does for us. So the radiation that Earth's field and Earth's thick air block, almost completely, before it ever reaches the ground, reaches the surface of Mars nearly unimpeded. Standing on Mars, even sealed in a suit, you are standing in a rain of high-energy particles that Earth has protected every living thing on its surface from for billions of years. There are two kinds of it. The first is galactic cosmic rays, the nuclei of atoms accelerated to nearly the speed of light by distant exploding stars, sleeting in from all directions across the galaxy, all the time. The second is solar energetic particles, the bursts the sun throws out during flares and storms, which can arrive with little warning and spike the dose hard for hours or days. On Earth, the magnetic field steers most of this away, and the atmosphere absorbs the rest. On Mars, both shields are missing, and the particles come down to the surface and pass through whatever is there, including a human body, breaking molecules as they go. We are not estimating this from theory. A rover named Curiosity carried an instrument to the surface specifically to measure the radiation, and it has been measuring it for years. On the ground, it found a dose of roughly 2/3 of a millisievert per day, every day, relentlessly. Put that into the shape of an actual mission, and the numbers get heavy fast. A trip to Mars and back, with a stay on the surface, would add up to something close to 1 sievert of total exposure. To give that a meaning, 1 sievert is about the entire dose a European astronaut is permitted across their whole working career, and it carries a measurable rise in the lifetime risk of fatal cancer. Spend around 3 years on the surface, which any real settlement means by definition, and you pass the career limit NASA sets for its astronauts and keep going. On Mars, you would cross an astronaut's whole career radiation budget and then simply keep living there, accumulating more, every day for the rest of your life. There is a way to block it, but look closely at what the way actually is. To stop galactic cosmic rays, you need a great deal of mass between you and the sky, meters of rock and soil piled overhead, or you go underground entirely and let the planet itself be the shield. A thin habitat wall does not do it. A dome, the image the dream always reaches for, the family looking up through clear glass at the pink Martian sky, is one of the most dangerous things you could actually build there, because glass and thin walls let the radiation straight through. So the real settlement is not a city under a dome. It is a warren of buried chambers, dug into the ground or roofed over with meters of Martian dirt, where people live shielded from the sky by the dead planet pressing down on top of them. Sit with what that means for the people who went. They crossed space for a new world, and the new world is so hostile that they cannot live on its surface at all. They live under it. Their days are spent in buried rooms with the radiation soaking into the rock overhead instead of into them, and the surface they travelled all that way to reach becomes a place they visit briefly, in a suit, for as long as the dose allows, and then retreat from back underground. The image of standing on Mars and looking up at an open sky is exactly the thing the radiation forbids. To survive the sky, you have to stop looking at it. And here is the honest uncertainty, which cuts in a way that should worry you rather than reassure you. We genuinely do not know the full long-term cost of living in that radiation, because no human ever has. The cancer numbers are estimates built largely on other kinds of exposure. The galactic cosmic rays include heavy, fast atomic nuclei that deposit their energy in dense tracts as they tear through tissue. And there is real concern and real laboratory evidence that this kind of radiation does specific damage to the brain and nervous system over time, damage we do not fully understand and cannot yet predict. The true risk might be close to the estimates. It might be worse. The body might cope better than we fear. We do not know, and the only way to find out for certain is to send people and wait, which is to say to make the people the experiment. That is the honest state of it, and it is not a comfortable one. The radiation is not even steady, which is part of what makes it so hard to live with. Underneath it all runs the constant sleet of galactic cosmic rays, the background that never stops. But on top of that, the sun throws sudden storms, bursts of energetic particles that can arrive with little warning, and drive the dose up sharply for hours or days. On Earth, our magnetic field and atmosphere shrug these off, and we never notice. On Mars, a large solar storm hitting settlers caught on the surface, away from heavy shielding, could deliver in a short time a dose that matters for the rest of their lives, and a severe enough one could be acutely dangerous. So life on the surface is not only the slow accumulation of the background, it is the gamble that the sun does not have a bad day while you are out in it, which means even the brief trips up from underground carry a risk that has to be watched and timed and feared. Carry the accumulation forward across a real life, and the weight of it sinks in. A settler does not spend a few days exposed, like a visiting astronaut. They spend years. The dose that would push a visiting crew near a career limit becomes, for someone living there, just the first stretch of a life sentence of exposure, the counter ticking up every single day, through every thin-walled trip to the surface, through every storm for as long as they live. The body has ways of repairing radiation damage, but those ways are not perfect, and damage that outpaces repair is how cancers start and how tissues age before their time. We are talking about people living their entire lives inside a dose rate that we would never knowingly allow anyone on Earth to endure. And there is the deeper worry I have to be honest about, the one we understand least. The heavy nuclei in galactic cosmic rays do a particular kind of damage, punching dense tracks of destruction through whatever they pass through, including the cells of the brain. Studies on the ground hint that this kind of exposure may harm the nervous system over time, affecting memory and thinking in ways that have nothing to do with cancer. We do not know how serious this is for a human over years, because we have never been able to watch it happen. It is entirely possible that long-term residents of Mars would face a slow erosion of the mind itself on top of everything else, and we would find out only by having sent them. The radiation is not just a known hazard with a known price. It is partly an unknown one, and the unknown part lands on the brain. Put the lifetime dose in plain terms. A person living on Mars would be absorbing radiation at a rate that, stretched across the decades of a life, climbs to totals we simply do not permit anyone to receive on Earth. Not workers in the most hazardous trades, not anyone. And every hour spent on the surface, above the shielding, adds to it faster. So the settlers would live by a budget no one on Earth has to think about, a budget of how much sky they are allowed before the accumulated dose becomes its own sentence. Time on the surface, the very thing they crossed space to have, would be the scarce and dangerous luxury rationed against a counter that never resets, while the safe life is the one spent below, in the dark, under the rock. There is no clean engineering escape from this, only trades. Pile on more shielding, and the structure becomes more massive and harder to build with the limited tools on hand. Go deeper underground, and the digging and the life support and the sheer claustrophobia all grow. Spend less time outside, and you give up the work and the mobility that the settlement may need to survive. Every answer to the radiation costs something else the colony cannot easily spare, and none of them make the surface safe to simply live on. They only move the danger around, trading exposure for mass, or mobility, or depth, on a world where all of those are already scarce. What gets me about the radiation, more than the numbers, is the contrast it draws with home. On Earth, you stand under the open sky your whole life and never think about any of this, because a magnetic field you cannot see and an atmosphere you never notice are turning aside and soaking up that same radiation every second for free, for everything alive. We get the shield for nothing, built into the planet, and we have had it for so long we forget it is even there. On Mars, there is no such gift. To get a fraction of the protection Earth hands every living thing without asking, a settler has to dig and pile rock overhead and live in the dark under it and ration their minutes in the open. The dead world gives nothing away. Every defense that Earth provides as a birthright has to be built on Mars by hand and maintained forever, and it is still worse than what you were born under and left behind. So now bury the settlement deep enough under enough rock, and you have answered even the sky. The vacuum is held off by sealed walls. The poison is managed. The radiation is blocked by living underground. Every external threat has, at least on paper, a defense, even if each defense is one more system that must never fail. But there is one more threat, and it is the one with no wall to hide behind, because it is not coming from outside the body at all. It is in the body. It is what happens to a human being over months and years, and possibly over generations, when it tries to live in a gravity only a third as strong as the one it was built for. Gravity on Mars is about 38% of Earth's. A little more than a third. And of every danger we have talked about so far, this is the one I find hardest to put down, because it is the one we cannot engineer our way around and cannot even measure in advance, and because of what it threatens, not the life of a settler, the possibility of a next generation at all. Start with what we do know, which comes almost entirely from the wrong experiment. Human beings have spent long stretches in space, on stations in orbit, but orbit is not low gravity. It is effectively no gravity, free fall, weightlessness. And we know what that does to a body, because we have watched it happen many times. The bones thin, shedding mass at something like 1% a month, because without weight to push against, the body stops spending energy maintaining a skeleton it no longer seems to need. The muscles waste for the same reason. Fluids that gravity normally pulls down into the legs shift up into the head and chest, puffing the face and, more seriously, pressing on the back of the eyes and changing their shape, degrading vision in ways that do not always fully reverse. The heart, with less work to do moving blood against gravity, weakens. A body in weightlessness is a body slowly being unbuilt, and astronauts fight it with hours of daily exercise and still come home diminished, needing time to recover. But Mars is not weightlessness. It is partial gravity, a third of Earth's, and here is the uncomfortable truth at the center of this whole subject. We have almost no idea what partial gravity does to a human body over years, because we have never studied it. Every long-term measurement we have is from zero gravity in orbit. There has never been a place to put a human in 1/3 gravity for months and watch what happens. We do not know whether a third of Earth's pull is enough to hold off the bone loss and the muscle wasting and the rest, or whether it merely slows a body's unbuilding rather than stopping it. We are guessing, and we are guessing about whether a human can stay healthy for a lifetime in the only gravity Mars has to offer. And then there is the question underneath that one. The question that I think is the true flaw of this entire video, and it is about the people who would be born there. No mammal has ever been conceived, carried through a full pregnancy, and grown to adulthood in low gravity. It has never happened, anywhere, not once. Every human who has ever existed was conceived, gestated, and grew up under the steady one gravity of Earth. And our entire biology of development, the way a body lays down bone, the way a heart learns to pump against weight, the way an inner ear learns balance, the way an embryo even knows which way is up, all of it developed under that pull and assumes it. We do not know what happens to a pregnancy in a third of that. We do not know whether an embryo implants properly, whether a fetus develops a normal skeleton and a normal heart, whether a child raised in that gravity grows a body that works. We have never run the experiment, and there is no way to run it without risking the child who is the experiment. Think about what that does to the whole idea of a colony. A settlement is not just a group of people surviving for a while. The entire premise of Mars as humanity's second home, as a backup, as a place the species continues if Earth fails, depends on people being able to live there across generations, to be born there, grow up there, and have children of their own there. Remove that and Mars is not a colony at all. It is a base. It is a posting, staffed by people sent from Earth, that ends when the last of them dies, unless Earth keeps sending more. And we do not know, we genuinely do not know, whether that limit can be crossed. The first child conceived on Mars would be the first test of whether human biology can begin and unfold at all in that gravity, and no one, no doctor, no scientist, no parent would be able to say beforehand whether that child would develop a body that works. The colony's future would ride on an experiment performed on its own children. That is the spike of this whole subject, the place the flaw drops out, and it is worth being honest about how it cuts, because it does cut both ways. It is possible that a third of Earth's gravity turns out to be enough. It is possible that bodies hold up better than they do in orbit, that pregnancies succeed, that children grow up healthy under that lighter pull, taller maybe, shaped differently maybe, but whole. We cannot rule that out because, again, the experiment has never been run, but that is exactly the point I cannot get past. The most important single fact about Mars as a home, whether our kind can even continue there, is a fact we do not have. Everything else, the air, the dust, the radiation, we can at least measure and plan against. This one we would only learn by going and having children there and finding out with those children whether it works. It is worth being exact about how little we have to go on, because the size of the gap is itself the point. We have run animals briefly in orbit, in full weightlessness, and we have flown a few short experiments. We have never maintained mammals through a full pregnancy and into adulthood at any reduced gravity, let alone at the specific 1/3 pull of Mars, let alone across the multiple generations a colony would require. There is no centrifuge in space large enough, no station on a low-gravity world, no data at all on the thing that matters most. So when someone tells you confidently that people will raise families on Mars, understand that they are not describing a solved problem or even a studied one. They are describing a hope about a biological question that has never once been tested on the single point that decides whether a colony is a beginning or an ending. And the question is not only whether a pregnancy can succeed, but what a body that grows up in 1/3 gravity even becomes. A human child builds its skeleton, its muscles, its heart, its sense of balance, all in response to Earth's pull, the constant downward force that tells the growing body how strong to become. Take that force away by 2/3 for the entire span of growth, from a single cell to an adult, and there is no reason to assume the result is a healthy Earth like human who happens to be lighter. The body might lay down too little bone, build too weak a heart, develop an inner ear that never calibrates correctly, grow in proportions we cannot predict. A person born and raised on Mars might never be able to come to Earth at all, their body unfit for the gravity their parents were built for. They would be something new, shaped by a world that was trying, the whole time, to kill them, and we would have no way of knowing what until they grew. There is something I cannot get past in that, on a level beneath the science. The first child born on Mars would not have chosen any of it. They would be the test subject of an experiment no one could consent to on their behalf. The experiment of whether a human can be made and grown in that gravity at all, with the answer written into their own body for better or worse, before they were old enough to understand the question. A colony that depends on that needs its children to turn out viable in order to continue, is a colony built on a gamble with its own unborn. And if the gamble fails, if it turns out that bodies cannot properly grow there, then everyone who went is the last of their line, and the settlement is not the seed of a new branch of humanity. It is a room full of people, far from home, watching the future fail to arrive. A colony does not continue on one successful birth either. For humanity to actually persist on Mars, you would need not a child, but generations of them, a population large enough and healthy enough to reproduce among themselves indefinitely, each generation growing up viable in that gravity and able to raise the next. Every link in that chain is the untested experiment repeated. If the gravity quietly weakens each generation, if bodies grown in 1/3 gravity drift further from working with each step, the colony could survive for a generation or two, and then simply taper into people who cannot have healthy children and end. From the outside, in the early years, it might even look like success. The failure would only reveal itself later in the children and then the grandchildren, when it was far too late to undo. And we cannot run the tests safely anywhere, which is the trap. We could in principle build a spinning station that creates 1/3 gravity and raise animals in it for generations to find out what happens before we ever risk a human child. We have not, and until we do, sending people to build families on Mars means running that experiment for the first time on human beings, on their own children, with no way to stop it once a child is growing, and no way to know the result until that child is grown. There is something I find genuinely hard about that, underneath all the physics. The most important question about Mars as a home can only be answered by gambling with the people who would be most helpless to consent, and the dream simply assumes the gamble comes up in our favour, with nothing behind the assumption but hope. And suppose, against all of this, that the biology somehow works, that pregnancies hold and children grow, a colony still cannot start from a handful of people, because a population that small breeds itself into trouble within a few generations, every line too closely related to the next, the same way any tiny isolated population on Earth runs into the dangers of too little variety. So a self-continuing Mars would need not a brave few, but a real population, many healthy people, having many healthy children who have many healthy children, all of them growing up sound in a gravity we have never tested on a single one. Each requirement multiplies the others. You do not need one gamble to pay off. You need the same gamble to pay off again and again, across hundreds of bodies and many generations, on a question we have never once answered. The more honestly you look at what it would actually take for humanity to continue on Mars, the more the whole thing rests on a hope we have never had any reason to hold. And there is a difference between surviving and being well that the dream tends to skip past. Even if bodies hold together in that gravity well enough to live, well enough to bear children who live, that is not the same as thriving. The adults sent from Earth would be slowly unbuilt by the low gravity and the radiation across their years there, growing weaker and more worn than they would have at home. The children grown in it might be viable and still not be sound, carrying weaker bones, weaker hearts, bodies tuned to a pull that does not match the one their species was made for. A colony could continue, in the narrow sense of not dying out, and still be a population of the chronically unwell, each generation a little less suited to anywhere, held together only by the machines and the medicine they can keep running far from home. That is a grimmer kind of survival than the word colony brings to mind, and it is well within the range of what the gravity unknown could deliver, and we would not know which way it goes until we had already sent the people and waited for the children. And notice what this does to the dead world. We started with a planet that lost its own ability to stay alive, that leaked its air and froze its water billions of years ago. Now we find that its deadness may reach further than that it may not even let our kind of life begin again on it, that a third of a gravity may be a wall our biology cannot build a child against. The deadness is not only in the thin air and the frozen ground and the unshielded sky. It may go all the way down into the body, into the cell, into whether a new person can be made there at all. That is as far into the dark as this goes, a world that cannot keep itself alive and may not let us make more of ourselves to replace the ones it wears down. All of this might still sound like a list of hard problems with engineering answers. So keep one question in your mind, because it is the one that decides everything, and I am going to answer it before the end. Can Mars ever actually be made into a home, a place a person could one day step outside and breathe, or is it permanently a world that kills what we send to it? Hold that. The answer is not the one the frontier story promises. A settlement on Mars would be the most isolated group of human beings who have ever lived, by a margin that is hard to take in. And the isolation is not loneliness in the emotional sense, though it would be that too. It is a hard physical fact about distance and time, and it means that the people there would be living without the one thing every other human community in history has had behind it: the possibility of help arriving. Mars and Earth are both moving around the Sun on their own paths, at their own speeds, and the distance between them is always changing. They line up favourably for a crossing only about once every 26 months, a little over 2 years apart. And even when they do, the trip is not quick. With the rockets we actually have, getting from Earth to Mars takes something like 6 to 9 months of flight. So the supply line to a Mars settlement is not a road. It is a narrow window that opens for a little while every couple of years, followed by most of a year in transit. If a colony needs something it does not have, the soonest that something could possibly arrive is measured not in days or weeks, but in years. Even talking to Earth is broken by the distance. A radio signal, travelling at the speed of light, the fastest anything can go, takes somewhere between about 3 and 22 minutes to cross from Mars to Earth, depending on where the two planets are in their orbits. That means a one-way message at best lands 3 minutes later, and at worst more than 20. There is no conversation. You cannot ask Earth a question and hear an answer for somewhere between 6 and 44 minutes. No one on Earth can talk a settler through an emergency in real time, cannot put a hand on the controls from here, cannot do anything in the moment but wait for the next delayed message to arrive. Whatever happens on Mars, the people on Mars handle it alone, in the moment, every time, because the speed of light itself will not let it be otherwise. Now put those two facts together against the way Mars kills. Everything keeping a settler alive is a system. The thing making breathable air is a system. The thing holding pressure is a system. The thing pulling water from the ground. The thing growing or storing food. The thing generating power. The thing scrubbing the carbon dioxide back out of the air they breathe. All systems, all of which must run continuously, because the moment enough of them stop, the dead world comes in. On Earth, when a critical system fails, help comes, often within hours. On Mars, if a critical system fails in a way the settlers cannot fix with what they have on hand, there is no help. Resupply is a year or more away, across a window that may not even be open. Rescue does not exist. There is no ship standing by, no plan to pull people off Mars in a crisis, and given the cost and time of reaching it, there realistically cannot be. They are out there with what they brought and what they can make, and nothing else, for as long as they live. I will be fair, because there is a real engineering answer here, and it is the same shape as the others. You cover the distance with stockpiles and redundancy. You bring years of spare parts, multiple backups of every critical system, enough supplies to ride out the gap to the next window. A well-planned settlement can survive a great many failures on its own, precisely because no help is coming and everyone knows it. So this, like the air and the dust and the radiation, is survivable in principle. But notice again, what survivable in principle keeps costing. It means the margin for anything truly unexpected, the failure you did not plan for, the run of bad luck, the thing that breaks that you cannot fix or replace, is thinner on Mars than it has ever been for any group of humans anywhere. On Earth, isolation is a hardship. On Mars, isolation means that the ordinary buffer every human society has always had, the chance that someone, somewhere, can reach you in time, is simply gone. This is the dead world enforcing its distance. It is not only that Mars is lethal, it is that Mars is lethal and unreachable at the same time, so that its lethality has no backstop. A dead world that was close, that you could flee or be rescued from, would be far less frightening than one that kills slowly and quietly and lets no help arrive for years. The distance turns every serious problem into a potentially final one. It means the people there are not pioneers with a lifeline home. They are people who have stepped permanently beyond the reach of everyone else alive, onto a surface that is trying to kill them, with the door closing behind them for years at a time. There is a particular cruelty in the way the trip itself works, which is that it does not allow second thoughts. When a crew sets out for Mars, they are committing to a path that, once underway, cannot simply be reversed. You cannot turn a ship around in the middle of interplanetary space and come straight home. You are on a months-long fall toward Mars, and then, if you land, you are on the surface until the planets line up again for a return, which can be a year or more away. There is no early exit. A crisis that on Earth would end with a flight home, or on a space station would end with a capsule ride down within hours, on Mars ends with the people living inside the crisis for as long as it takes, because leaving is not an option that exists on demand. They are committed in a way no explorers in history have ever been committed, with the way back closed for years at a stretch. Live inside the communication delay for a moment, because it changes the texture of every hard moment. Something goes wrong, a fire, a breach, a medical emergency, and the people there cannot call for help in any way that means anything, because the nearest expert who is not already with them is at least 3 minutes away by the speed of light, and as much as 22 minutes away, and that is one direction. Ask a question and the soonest you could hear an answer is twice that. So every fast-moving emergency is handled entirely by the few people present, with whatever knowledge and supplies they have, while Earth finds out what happened only after it is already over, and can do nothing but send advice that arrives too late to matter. The settlers are not just far away. They are, in every urgent moment, completely on their own, and they know it. The supply problem runs deeper than just the long wait, because it means everything has to be foreseen. On Earth, if a part breaks, you order another, and the entire planet of factories and warehouses stands behind you. On Mars, there is no ordering anything. Every spare part, every replacement, every component that might fail across years of operation has to have been either carried along in advance or be manufacturable on site from Martian materials, which is an enormous problem of its own. Building the means of manufacture on a dead world, a failure of something nobody packed a spare for and could not make, is simply unfixable, and an unfixable failure of anything critical is fatal. The settlers live inside the limits of what they thought to bring, with no way to reach back for the one thing they forgot. And then there is the weight of the isolation on the people themselves, which is not a small thing, even though it is the kind of thing engineering plans tend to leave out. A small group of human beings, sealed in buried chambers, unable to step outside without a suit, unable to leave, unable to speak with anyone beyond their own number, without a delay that kills conversation, for years, with the knowledge that no one can reach them and that any serious mistake is final. We do not have a good record of how the human mind holds up under that, because no one has ever been that isolated for that long. It is one more unknown stacked on the others, and it is the kind that does not show up in a list of systems because it happens inside the people the systems are keeping alive. Step back and the shape of it is plain. Every human community that has ever existed, no matter how remote, has lived with the background fact that help in principle could come. A ship could arrive, a message could bring aid, someone, somewhere could reach you. A Mars settlement is the first place humans would live where that is simply not true, where the distance is so great and the windows so narrow that the people there have stepped permanently beyond rescue. That is not an adventure with a rope back to safety. It is a one-way step onto a lethal surface with the rope cut for the rest of their lives. Consider what a single resupply actually costs, because it shows how thin the lifeline really is. Sending anything to Mars means building a rocket, launching it during the narrow window, and waiting months for it to arrive, at a cost so large that each delivery is a major undertaking in its own right. This is not a truck route you run as needed. It is a handful of chances per decade, each one enormous, each one planned years ahead. A settlement cannot lean on resupply the way any outpost on Earth leans on the supply lines behind it. It has to be very nearly self-sufficient, which on a dead world means building the means to make its own air, water, food, power, and spare parts out of poisoned dust and frozen ground, an industrial base from nothing before the supplies it arrived with run out. No human settlement has ever had to bootstrap itself that completely, that fast, that far from help. And then there is medicine, which the dream rarely mentions. On Mars there is no hospital, no specialist a flight away, no deep bench of doctors and machines and blood supplies to fall back on. There is whoever came, with whatever they could bring. A serious injury, a burst appendix, a cancer, a complicated birth, the ordinary medical emergencies that Earth handles routinely every day, on Mars could easily be death sentences, because the people and equipment that would save you on Earth are tens of millions of miles away and months from arriving. The settlers would be living not only beyond rescue, but beyond medicine, in bodies being slowly worn by radiation and low gravity, with only each other and a limited kit between them and whatever goes wrong inside them. And the crossing to get there is its own dose of the danger before a settler ever sets foot on the surface. Out in open space, between the planets, there is even less shielding than on the Martian ground, because Mars at least has a thin sliver of air and the bulk of the planet under your feet blocking half the sky. In transit there is only the thin hull of the ship. The same instrument that measured the surface dose measured the trip, and found the radiation in deep space running at something like 3 times the rate on the surface of Mars, day after day, for the 6 to 9 months of the crossing. So the people who go absorb a heavy share of their lifetime dose, simply getting there, strapped inside a thin shell falling through the most exposed place of all. And then they arrive, already counted down, to begin accumulating more. The distance does not only deny them rescue, the crossing itself is one of the most irradiated places a human body can be, and there is no way to reach Mars without enduring it. Distance, at least, you can plan around. You can stockpile, you can build in your backups, you can accept the years of solitude and prepare for them. But Mars has a way of overwhelming the plan on a schedule of its own, with a single kind of event that arrives without much warning and does not pass in an afternoon. It can last for weeks, it can wrap the entire planet, and it goes straight at the one resource a settlement on a world this far from the sun would most depend on. Mars has weather, and its worst weather can swallow the entire planet. The same fine dust that poisons the ground and grinds down the machines gets lifted into the thin air by the wind, and under the right conditions it does not stay local. A dust storm on Mars can grow until it wraps the whole world, every region of the surface under the same brown pall at once, and once it reaches that size it can last not for hours or days but for weeks, sometimes months, before it finally settles out. We have watched one of these do its work, and watched it kill. In the year 2018, a dust storm grew until it covered all of Mars, and the sky went so dark with suspended dust that the sunlight reaching the surface dropped to a fraction of normal. On the surface at the time was a rover named Opportunity, which ran on solar power, which had been working for many years past the mission it was built for. As the storm darkened the sky, its panels could no longer gather enough light to keep it powered. It went quiet, waiting for the dust to clear and the light to return. The storm lasted long enough that the rover's reserves ran out in the cold and the dark, and it never woke again. A planet-wide storm reached out, took away the sunlight and ended it. Now make that a settlement instead of a rover. A colony on Mars, far from the sun to begin with, would lean heavily on whatever power source it brought, and if any part of that power came from sunlight, a global dust storm could choke it off for weeks or months at the worst possible time, while every life support system underneath kept demanding energy to run. And the dust does more than block the light. It settles onto every surface, coats the panels that are left, works its way as always into the seals and joints and moving parts, so that the storm does not just starve the colony of power while it rages, it degrades the equipment that has to recover afterward. The planet does not strike once and stop. It buries, slowly, and then it buries again. This is the quality of Mars that does not fit on a poster but matters more than almost anything that does. The planet is relentless. It is not only that there are a handful of dramatic ways to die, the vacuum, the cold, the radiation, it is that the dead world is working against everything you build, all the time, in 1,000 small ways. The dust abrades and infiltrates and accumulates. The cold stresses every material through brutal daily swings. The near vacuum pulls at every seal. The radiation degrades electronics and materials over time. Nothing on Mars is trying to keep your settlement alive, and everything about Mars is, simply by being what it is, wearing it down. Maintenance is not a chore there, it is the whole job, forever, against a planet that never stops pushing back. I will give the engineering its due once more, because it deserves it. You can harden a settlement against the storms. You can run on nuclear power instead of sunlight, so that a darkened sky does not starve you. You can design for the dust, seal against it, build in the redundancy to absorb the wear. None of this is impossible, but by now you can hear the pattern in it, the same note struck over and over. Every single threat on Mars is survivable in principle, and only in principle. Each one demanding its own flawless, unfailing system. Each one another way the colony dies if the management lapses. Air, poison, radiation, distance, storms, and under all of them the gravity we cannot even test. The dead world does not present one wall you climb over and then you are safe. It presents an unending list of ways to die, every one of which must be held off perfectly, at once, forever. The storms are not rare freak events either. Mars has a dust storm season, tied to the part of its orbit where it swings closest to the sun and the warming kicks the weather into higher gear. Most years bring regional storms. Every few Martian years, those can grow and merge into the planet-wide events that darken the entire world. So a settlement would not be facing a once-in-a-lifetime disaster it could hope to dodge. It would be facing a recurring season of danger, year after year, with the worst version arriving on a schedule loose enough that you cannot predict the bad ones precisely, but certain enough that you know they are coming. You would build your whole life around surviving a darkness that returns, via drones. The dust does a subtler harm too, through the static charge it carries. Because the particles are charged, they cling to surfaces and to each other, building up in ways that ordinary dust does not, and that charge raises the possibility of electrical discharges, sparks, in an environment full of equipment that cannot afford them. The same property that makes the dust stick to a solar panel and an airlock seal makes it a hazard to the electronics it works its way into. Cleaning it off is endless and imperfect because it clings and because there is always more, and because going outside to clean anything means suiting up against the vacuum and the cold and the radiation to do it. And the storms leave damage behind even after they pass. A settlement that rode out weeks of darkness on dwindling power would come out the other side with dust caked over everything, panels to be cleared, systems to be checked, the slow work of recovery beginning just as the reserves are at their lowest. The planet does not hit once and let you rebuild in peace. It coats what it darkened, fouls what it coated, and lines up the next season behind the one you just survived. Living there would mean never quite finishing the recovery from the last storm before bracing for the next. This is why the honest picture of Mars is not a list of dramatic dangers but a single, grinding, unrelenting one. People think of the threat as a few big enemies: the cold, the vacuum, the radiation, each of which you defeat once and move past. The truth is closer to a planet that is, in its every feature, slowly and continuously hostile to the existence of anything alive and anything built. The dust that grinds, the cold that flexes every joint, the vacuum that pulls at every seal, the radiation that degrades every material, the storms that return every year. There is no winning against that. There is only holding it off, with perfect maintenance forever, on a world that has all the time in the universe and is in no hurry. Start with how little sunlight Mars gets, because it shapes everything about power there. Mars is half again as far from the sun as Earth is, and sunlight weakens with distance, so even on a clear day at noon, the surface of Mars receives less than half the sunlight that reaches the top of Earth's air. The sun is a smaller, fainter thing in the Martian sky, and the energy it delivers is correspondingly thin, so solar power on Mars starts out weak before anything goes wrong, which means a settlement leaning on it needs large arrays just to manage in good conditions. And then the dust season comes, and the storms, and that already thin sunlight is cut to a fraction of a fraction, for weeks exactly when the cold makes power most precious. A world that hands you half the sunlight and then takes most of that away on a schedule is not a friendly place to run on light. That is why serious plans reach for nuclear power instead, carrying the energy source with them rather than gathering it from a weak and unreliable sun. And that can work, but notice that it is one more thing to carry across that long supply window, one more complex system to maintain perfectly with no factory behind it, one more way the settlement dies if it fails and cannot be fixed. Whatever the power source, the pattern holds. The dead world does not provide. It does not offer easy energy any more than it offers breathable air or clean ground. Everything that keeps the lights on and the heaters running and the air breathable has to be brought or built and then defended without pause against a planet that is cold, dim, dusty and indifferent. There is a quiet trap in the cold and the power together, a way the two can close on a settlement at once. The cold is constant and brutal, so heating is not a comfort but a life support function, running always, drawing power always, because a habitat that loses its heat on a world that averages 60 below does not get uncomfortable, it freezes, and power, on a planet this far from a dim sun, is the scarcest thing there is. Now bring the storm. The same event that blots out the sunlight and starves the power is the event during which the cold bites hardest and the heating is needed most. Power falls exactly when the demand to stay warm rises, and a settlement caught short rides that gap down, the temperature dropping inside as the reserves drain, every system that needs warmth and energy competing for a supply that the darkened sky has cut. The planet does not need many ways in. It only needs the cold and the dark to arrive together, which on Mars they do. Hold on to the rover that went silent in the storm, because it is the closest thing we have to a preview. It was built well, it had worked for many years, and none of that mattered when the planet-wide dust took the sunlight away for long enough. It did not fail because of a flaw. It failed because Mars, doing the ordinary thing Mars does, removed the one resource it needed and kept it removed past the point of recovery, and then the cold finished it. A settlement is a far more complicated machine than a rover, with far more that can go wrong, and far more riding on it, facing the same planet with the same habits. The lesson of that silence is not that we build badly. It is that on Mars, building well is not enough, because the world itself will, sooner or later, reach for the thing you cannot do without, and it has every kind of patience, and it is in no hurry at all. So every problem we have looked at has an answer of a kind, even if each answer is a brittle one that must never fail. And that naturally leads to the question that sits underneath the whole dream of Mars, the one I parked earlier and promised to come back to. If the planet as it is fights us at every turn, then why accept the planet as it is? Why not change it? Why not warm Mars up, thicken its air, melt its water, and turn it from a dead world into a living one, so that none of these defenses are needed at all? This is the oldest and most hopeful idea in the entire Mars dream, the belief that we could make it into a second Earth. So let us take it seriously and see exactly where it breaks. Here is the answer to the question I asked you to hold. Mars cannot be turned into a second Earth, not with anything we can build now or in any near future we can describe, and the reason is not a lack of ambition. The reason is the planet itself. The dream of terraforming runs straight into a wall that Mars builds, and once you see the wall, the dream stops looking like a plan and starts looking like a wish. The standard idea is simple enough to state. Mars has carbon dioxide frozen into its polar caps and locked into its soil, and carbon dioxide is a greenhouse gas. So the plan is to release it, free the frozen carbon dioxide back into the air, thicken the atmosphere, let the thicker air trap heat and warm the planet, and keep going until it is warm enough and thick enough for liquid water to be stable on the surface again, warm the world, raise the pressure, melt the water, and Mars wakes up. That is the vision. The problem is that when you actually go and measure how much carbon dioxide is there to release, the numbers do not come close. This has been studied carefully, using 2 decades of data from spacecraft mapping the planet's ice and minerals and measuring how the atmosphere is built. The finding, published by Jackowski and Edwards, is blunt. There is not enough accessible carbon dioxide left on Mars to do it. If you released everything that could realistically be mobilized, every bit of carbon dioxide in the ice caps and the easy reservoirs, you would not even approach the pressure you would need for liquid water to be stable. You would need to raise the pressure towards something like the full weight of Earth's atmosphere, and what is actually available on Mars would get you a small fraction of the way. The cupboard is close to bare. The carbon dioxide that once made Mars warm is mostly the carbon dioxide that was stripped away into space billions of years ago, and it is gone. And it gets worse because there is a deeper objection that does not even depend on the inventory. Suppose you found the gas anyway. Suppose by some means we do not have, you thickened the Martian air into a warm, dense atmosphere. The very same thing that killed Mars the first time would begin killing it again, immediately, for the very same reason. Mars still has no magnetic field. The shield never came back, so a new atmosphere, however you built it, would sit just as exposed to the solar wind as the old one did, and the stripping would start over, carrying your hard-won air back off into space. You would be pouring an atmosphere into a planet that cannot hold one. The deadness of Mars is not a wound that happened once and could be healed. It is the planet's stable condition. With no magnetic field, dead and airless is simply what Mars is and what it returns to. So the honest answer to the hook, to the question of whether Mars can ever be made into a home where a person could step outside and breathe, is no. Not with present technology, and not with the near future technology we can actually foresee. The most generous reading keeps the door open only to far future engineering we cannot specify or build. Ideas like wrapping the entire planet in an artificial magnetic shield, projects on a scale and timeline that have nothing to do with any of us or our children or their children. The schemes that would even attempt it run to centuries and millennia at the very least, and rest on capabilities no one has. Within any timescale that means anything to a human life, Mars stays exactly as lethal as it is tonight. There is no terraformed Mars coming to save the settlers from the dead world. The dead world is the only Mars on offer. I want to be careful and not overclaim, because this is where it would be easy to. I am not telling you it is forbidden by physics for any conceivable civilization ever to alter Mars. I am telling you something narrower and, I think, more useful. Nothing we can build now or soon makes Mars a place a human can live unprotected. The gap between what terraforming would require and what we can actually do is enormous, and the planet's missing magnetic field means even success would unravel. So when the dream promises a green Mars, a blue sky, an open field under an open heaven, understand that it is promising something no path we can actually trace leads to. It is not a plan with hard steps. It is a hope laid over a planet that has already shown us, once, exactly how it ends. It is worth walking through the rescue plans for the magnetic field because they show the scale of what fixing Mars would actually require and how far it sits beyond us. One proposal is to place an artificial magnetic shield in space between Mars and the Sun, a structure generating a magnetic field strong enough to deflect the solar wind around the entire planet, doing the job the lost core once did. Set aside whether we could build such a thing, which we cannot, and notice what it tells you. To give Mars even a chance at keeping an atmosphere, you would have to permanently replace, with technology, a planetary scale feature that Mars cannot generate for itself. Not improve Mars, not nudge it. Wrap the whole planet in an artificial substitute for the thing it lost, and keep that substitute running forever, because the moment it failed, the stripping would resume. That is not terraforming. That is putting a dead world on permanent life support from the outside. The other schemes scale the same way, into the unreal. If there is not enough carbon dioxide on Mars to thicken the air, some propose importing it, redirecting comets and asteroids rich in frozen gases to crash into the planet and add their volatiles to the atmosphere. The numbers there are their own answer. It would take not a few such impacts, but many thousands of them, an industrial program of bombarding a planet with redirected worldlets over a span of time that dwarfs all of recorded history, to make a dent. And at the end of it, with no magnetic field, the solar wind would still be carrying the result away. Every serious path to a living Mars ends either in technology we have no idea how to build, or in timescales of centuries and millennia at the very least, and most of them end in both, and the planet's missing shield means even success would slowly unravel. So why does the dream survive all of this? I think it survives because it is a good story, maybe one of the best we have, and because we want it to be true. The idea of a second Earth, a fresh start, a frontier where we begin again, speaks to something old in us, the part that has always believed there was another valley over the next ridge. It is a hopeful story, and hopeful stories are hard to kill with facts, especially facts about pressures and doses and gravity that are difficult to feel. But a story being beautiful and being true are different things, and on the specific question of whether Mars can be made into a home for us, the facts are not close, and they do not bend, no matter how much we would like them to. And the honest version of the science is not even a maybe with a long enough lever. It is that within any timescale that touches a human life, a human family, a human civilization as we understand the term, Mars stays the lethal dead world it is tonight. The terraformed Mars of the dream, the blue sky and the open field, is not a destination at the end of a hard road. It is, as far as anything we can actually do is concerned, a place that does not exist and that we cannot reach, a hope laid over a planet that has already shown us its real and final face. There is a plain physical reason small worlds like Mars cannot stay alive, and it is worth stating because it is the bedrock under everything. Holding onto an atmosphere over the long run takes two things: enough gravity to keep the gas from drifting away, and enough protection to keep it from being stripped away. Mars is small, so its grip is weak, only about a third of Earth's pull, and it lost its magnetic protection when its core cooled. A world that is both weakly gravitied and unshielded is a world that loses its air slowly but surely and cannot get it back. This is not a problem you fix by pouring in more gas, because the planet that lost the first atmosphere would lose the second one the same way. The deadness of Mars is not a stage it is passing through. It is the resting state of a small, cold, unshielded world, the condition it returns to no matter what you do to it, short of changing the planet itself. So the dream of terraforming is, at bottom, a wish to undo the size and the cooling and the lost core of an entire planet, and there is no version of that within reach. We can talk about shields in space and bombarding the planet with comets, and the talking is fun, but the gap between the talk and anything buildable is so wide that it functions for any real purpose as never. I think it is worth being honest that the dream often serves as a kind of deflection, a way of not looking at the harder truth. As long as Mars might someday be made livable, we do not have to sit with the fact that it is not, and that there is nowhere else, and that this changes what we owe the only world that is. The terraforming dream lets us keep the comfort of a backup by pushing its delivery date out past where anyone can check. Set the timescales against a human measure, and the dream dissolves on contact. The schemes that might, in some far future, do something to Mars run to centuries and millennia at the very least, and the planet's own slow processes run to millions of years. Against that, the whole of recorded human history, every city and empire and invention, every name we remember, fits inside a span of a few thousand years. We are talking about projects that would take longer than civilization has so far existed to maybe begin to change a planet that would then slowly undo the change because it cannot hold an atmosphere. There is no version of this that arrives in time to be a backup for anyone now alive, or their children, or any generation we could call ours. The terraformed Mars is always somewhere past the horizon of everyone who could ever check on it, which is another way of saying it is not a plan at all. It is a promise that never has to come due. And notice that the failure is not a matter of degree, where a little more effort buys a little more progress until one day you arrive. It is a wall, not a hill, with the carbon dioxide gone to space and the magnetic field gone with the cooled core. The two things terraforming would most need are the two things Mars most permanently lacks, and no amount of pushing on the parts we could reach changes the parts we cannot. You could spend centuries releasing every gas the planet still holds and end up with an atmosphere still far too thin to walk in, still being stripped away, still over a frozen and poisoned ground. The effort would not be slow progress toward a living Mars. It would be enormous effort spent discovering, in detail, across generations, that the planet cannot be made to hold what life requires. The wall does not move, it only reveals to anyone who pushes on it long enough exactly how solid it is. Which forces the real question, the one underneath the entire dream, and it is no longer a question about Mars at all. It is a question about us. If Mars is lethal in every way we have catalogued, if it cannot be reached for rescue and cannot be fixed into a home, if it may not even let our children develop in its gravity, then it is not, by any honest reading, a backup for humanity. So why do we keep saying that it is? Why is the idea of Mars as our second home so powerful, so persistent, when everything we actually know about the place argues against it? And that question matters more than any single fact about the planet, because the answer is where Mars stops being a story about another world and becomes a story about how we treat this one. The belief that Mars is our backup is not just wrong, it is dangerous, and the danger is aimed back at Earth. I want to make that case carefully, because it is the heart of why this video exists, and because it is the one place where I am no longer only reporting facts about a planet, and have started saying what I think they mean. Lay the facts in a row. Mars is lethal on contact, killing an exposed body in seconds. Its ground is poisoned and its sky is unshielded. It is too far for rescue and too far for resupply on any quick timescale. It cannot be terraformed into a living world by any means we have or can foresee, and it may not even allow our children to develop in its gravity. every honest fact about Mars points the same direction, and the direction is that a human settlement there is far more likely to fail than to flourish, and that the planet will never be a place humans live the way we live on Earth. That is not a frontier waiting to be tamed. That is a wall. Now set that against the way Mars is sold. It is sold as insurance, the backup planet, the second home that means humanity is not keeping all its eggs in one fragile basket, the place we go if Earth fails us or if we fail Earth. And once you have actually looked at Mars, you can see that this gets the logic exactly backward, because there is no policy to collect on. An insurance policy pays out when you need it. This one cannot. If Earth became as damaged as the worst futures fear, it would still, on its very worst day, be incomparably more livable than Mars on its best one. A ruined Earth would still have breathable air, drinkable pressure, a protecting magnetic field, soil without a thyroid poison in it, and the one gravity our bodies and our children are built for. There is no disaster that makes Mars the better option, because Mars is not a lesser Earth. It is a dead world. The backup does not exist. And here is why a backup that does not exist is worse than no backup at all. A false safety net changes how people behave on the ledge. If part of us believes, even quietly, even as a background comfort, that humanity has somewhere else to go, that the species continues out there if this world breaks, then the stakes of breaking this world feel a little lower than they are. The one living planet we have, the only place in the known universe where a human can step outside and simply breathe, gets treated as slightly more disposable, slightly more like something we could afford to lose, because the story says there is a spare. There is no spare, and believing there is makes us a little more careless with the only thing that has ever actually kept us alive. I want to be fair here, because this is where the science hands off to judgment, and reasonable people who love space land in different places, and I am not trying to flatten that. Going to Mars, exploring it, sending people to walk on it and learn from it, can be worth doing for many reasons. It drives discovery. It tells us how planets live and die, including our own. It answers the old question of whether we were ever alone on it. None of that requires pretending Mars is a refuge, and the case I am making is narrower than no one should ever go. The case is this: Mars is not a backup for Earth. It cannot become one, and treating it as one quietly changes how much care we think the only living world is owed. You can be all for exploring Mars and still need that part to be true, because it is. So the dead world has a use after all, but it is the opposite of the one the dream assigns it. It is not a refuge we are saving for later. It is a warning we are refusing to read. It is a planet that had air and water and warmth, that may even have had the start of life, and that lost all of it and became the lethal, frozen, poisoned, airless place we have spent this whole video walking across. It sits one planet over from us as a finished example of how completely a world can die. The honest thing to do with a warning like that is not to pack our hopes onto it. It is to look at the living world we are standing on and grasp, finally, how rare and how fragile and how unrepeatable it actually is. The pull of the frontier is old, and I do not want to be glib about it, because it has done real things. The belief that there is always somewhere new to go, somewhere to start over, has driven exploration and discovery for as long as there have been people, and some of what it drove was genuinely worth doing. So when the dream casts Mars as the next frontier, it is tapping into something deep and not entirely foolish. But every frontier in human history, however hard, was still Earth. It had air, it had water you could eventually find. It had a sky you could stand under, and a gravity your children could grow in. The thing that makes Mars different from every frontier that came before is that it is not a harder version of home. It is the absence of home in every direction permanently. Calling it a frontier borrows the comfort of all the frontiers that were survivable and lends it to one that is not. There is a cost to the belief that is easy to miss. And it is not mainly about money or rockets. though there is an argument there too about where enormous effort and attention get pointed. The deeper cost is moral, and it is quiet. If a part of our culture genuinely believes that humanity has a second home in progress, that the species has somewhere to go if this world fails, then the unspoken stakes of failing this world drop, not consciously, not in any one decision, but as a background setting, a faint permission. The only planet that has ever held us, or ever will within reach, gets filed, just slightly, under things we could replace. And nothing about the actual Mars supports that filing. It is the most expensive and least convincing insurance policy ever imagined, sold against a loss it could never cover. I want to hold the door open for the people who love Mars, because many of them are not confused, and the disagreement here is real and worth respecting. You can think a crewed mission to Mars is one of the great things our species could attempt, worth the risk and the cost, for the discovery and the daring of it, and still agree with every word of the case I am making, because that case is narrow. It is only this: Mars is not a backup for Earth. It cannot be made into one on any time scale that matters, and the belief that it is changes, by a little, how carefully we treat the one world that actually works. You can plant a flag on Mars for the right reasons. You just cannot call it a lifeboat, because it will not float, and believing it will makes us worse sailors of the only ship we have. If you want a backup for Earth, there is exactly one, and we are already standing on it. Earth is its own backup, the only one there is or will be within reach, and the way you protect a backup is by not destroying the original, because they are the same thing. Every bit of effort that goes into believing in a second home is effort not spent grasping how singular the first one is. We have one world with breathable air, one with a shield against its star, one with oceans and soil that is not poison, and a gravity our children grow in without a second thought. It is not the first of several, it is the only one, and the dead planet next door is the proof, the control case, the picture of what we have when this is gone, which is nothing we can live on. That is the real use of Mars, and it is a use worth the cost of going to see it. Not as a refuge, but as the most convincing argument for Earth that exists. You cannot stand at the edge of the Grand Canyon and the edge of a fresh grave and confuse the two, and Mars, looked at honestly, is the grave. It tells you in the plainest possible terms what a world is worth by showing you one that lost everything that made it a world. If going to Mars teaches us that, if it cures us of the idea that we have somewhere else to go, and sends us back to this planet understanding at last how rare and how fragile it is, then the trip will have been worth every danger I have spent this whole video laying out. Just not for the reason the dream gives. And there is something I want to say plainly about where the effort goes, while being fair to the people who disagree. The genius and the daring and the resources it would take to even attempt a self-sustaining outpost on a dead world are real and considerable, and I do not think wanting to point them outward is foolish or wrong. But the same genius, turned the other way, toward keeping this living world living, toward not losing the air and water and climate we already have and that already work, would be spent on the one planet where success is actually possible. Mars asks us to build, at unthinkable cost, a fragile imitation of conditions Earth gives us for free. The honest comparison is not between a living Earth and a living Mars. It is between protecting the one habitable world we have and chasing a second one that the facts say we cannot make. Put that way, the choice of where to place our hope looks different and I think clearer. The deepest cost of the dream is the one that never announces itself, because it lives in how we hold the value of this world. When a culture half believes it has a spare planet in progress, the original stops being irreplaceable in the quiet back of the mind, and irreplaceable is exactly what Earth is and what it needs us to keep treating it as. You do not have to make a single conscious decision for this to matter. It works as a background permission, a faint sense that the stakes here are not total, that there is a door out if it comes to that. There is no door. The only world that has ever kept a human alive without a machine wrapped around them is this one, and the belief in a backup quietly tells us otherwise, and a belief that tells us the truest thing we have is more disposable than it is not a harmless dream. It is the most expensive error we could make, measured against the only thing we cannot replace. Which leaves only one thing left to say, the plainest version of what all of this comes to, once you stop calling Mars a frontier and look at what it actually is. Mars is not humanity's second chance. It is a corpse, and it is a mirror. Pull everything we have walked through into one place, and that is what is left. Mars had water running on its surface, a thick enough atmosphere to hold that water, and a magnetic field to shield it all, and 4 billion years ago it lost the field, and then it lost the air, and then it lost the water, in that order, until the warm, wet world became the dead one we have been standing on tonight. What remains kills an exposed body in seconds, poisons the ground underfoot, pours radiation down from an unshielded sky, hides the sun behind planet-wide storms, lies too far for any rescue, cannot be fixed by any means we have, and may not even let our gravity grow a child. A settlement there is far more likely to become a grave than a city. And the thing the dream gets most wrong is where it places the fear. The fear is supposed to be about difficulty, about how hard Mars will be to settle, as though the only thing between us and a second Earth is enough engineering and enough will. That was never the real weight of it. The real weight is what Mars is. It is proof, sitting one planet away, of how completely and how permanently a world can end. It is what a planet looks like after its air is gone and its water is gone and its chance is gone, and it shows us that this is not a rare or far-fetched fate for a world, because it happened right next door to a planet that was once warm and wet and might have been on its way to something. The terror of Mars is not that it is hard to live on, it is that it is easy to die as a world, that Mars already did, and that the only planet we know of where the dying has not happened is the one under our feet. Hold the whole shape of it in your mind at once, because the argument only lands when the pieces are together. A planet that died 4 billion years ago, when it lost its magnetic shield and bled its air into space. A surface that boils the water out of an unprotected body in seconds. A ground laced with a thyroid poison and buried in clinging, abrasive dust. A sky pouring down radiation that forces the living to hide beneath the rock. A gravity so much weaker than ours that we do not know whether a child can even be grown in it. A distance so great that no rescue can come and no conversation can be had. Storms that swallow the whole planet for months, and no way to fix any of it, because the air it would need is gone and the planet cannot keep a new one. Every one of those is true at the same time, on the same world, and that world is the one we keep calling our second home. None of this is an argument against looking at Mars, or learning from it, or even setting foot on it. It is an argument against lying to ourselves about what it is, and what it is, once you have looked honestly, is not a destination, it is a demonstration. It is the clearest example we will ever have, close enough to touch with our machines, of how a world that had a real chance ends up dead, and stays dead, and cannot be brought back. That is worth knowing. It might even be the most useful thing Mars has to teach us, if we are willing to learn it instead of papering over it with a hope. I keep returning to one image from all of this, and it is not a frightening one, just a true one. It is the gravity, not the radiation or the vacuum, which are obviously deadly, but the quiet fact that we do not know whether a child can grow in 1/3 of Earth's pull, and that we never built the simple spinning laboratory that could have told us before we risked anyone. It captures the whole thing for me. The way the dream runs ahead of the knowledge. The way we are ready to send people to build families on a world before we have checked whether their bodies can be made there at all. That gap between what we hope and what we have actually confirmed is the dream of Mars in miniature, and it is why I cannot treat it as the comfort it is sold as. So bring it all the way back to where we started, to the body standing on the surface in the cold, thin air, the water beginning to boil out of it in seconds, That is not an edge case or a worst outcome. That is simply what the surface of Mars does, today, to the kind of life we are, and everything we have walked through since only widened the circle of the same fact. The air, the ground, the sky, the gravity, the distance, the storms, the impossibility of the fix, all of it says the one thing the cold open said, that this is a world arranged to kill what we would bring, and that it already killed itself long before we arrived to misread the ruins as a chance. We have been calling a grave a garden. That is the whole of it, and it is worth saying once more without flinching before I tell you what I think it means. Whether that should leave you in despair or in resolve is not something the science can decide for you, and I will not pretend it can. The facts do not tell you how to feel. They only tell you the one thing that is true regardless of how you feel about it, which is that there is one living world within reach, not two. There is here, and there is the dead one next door, and there is nothing else we can get to. So before I let you go, let me tell you what all of this has come to mean to me, standing at the end of it, having looked at Mars as honestly as I know how. Here is what I keep coming back to. We did not find Mars and decide it was dead. Mars died long before we were here to watch, 4 billion years ago, when it lost the magnetic field that held its air, and the solar wind carried its atmosphere away into space, and the water that carved its valleys froze or escaped, and the warm, wet world went cold and bare and still. That already happened. We are looking at the corpse, and we have decided the corpse is our future. I understand the pull of it, the idea that if Earth fails we have somewhere else to go, but everything we actually know about Mars says the same thing. It will not hold us. The air would kill a body in seconds, the ground is poisoned, the sky has no shield, and we do not even know whether a child could be carried and grown in its gravity at all. A settlement there is far more likely to become a grave than a city, and the planet cannot be fixed because the air it needs is gone and Mars cannot keep a new one. So when people call Mars our backup, I think they have it exactly backward. Mars is not the second chance that saves us from losing Earth. It is the proof of how completely a world can die and how little of it ever comes back. The danger was never that we would fail to reach Mars. The danger is that believing in it lets us treat the one living world we have as something we can afford to lose. We cannot. There is no second home. There is only this one and the dead one next door, showing us how it ends. If you made it all the way out to the dead world with me, a like or a subscribe helps the next one reach someone who would have wanted to come along. Sleep well